Welcome to New Domains, the podcast where we explore how AI is set to transform our world and the way we interact with it. Hello, everybody, and welcome to the first real episode of the Reframers, or the Reframer, talking about AI. Today, we're really just going to do a background dive into what is artificial intelligence. What does it mean? What are the associated terms that you often hear with AI? And we're also going to discuss quickly a history of artificial intelligence, some of the different more common types of artificial intelligence and machine learning, as well as challenges for AI in the future. So first off, what is artificial intelligence? We throw the term around a lot ever since ChatGPT was first released. But basically, artificial intelligence is technology that enables computers and machines to simulate human intelligence and problem-solving capabilities. So what we're going to cover today is not an extensive list of different techs that fall under the AI umbrella, but I just wanted to give an overview of some of the common different types of technology that we are likely to encounter in the series as we go forward. As I mentioned, AI is an umbrella term encompassing a wide range of techniques, technologies, and methods to teach computers how to think, quote unquote, like humans. Phrases like machine learning, neural networks, and deep learning are like Russian nesting dolls, with machine learning being the largest, then neural networks, then as the smallest doll, deep learning. And we're going to cover today what each of those specific phrases mean. One of the key things to keep in mind during all of these discussions, not just today, but in the rest of the series as well, is that someone or a group of someone's has to train these models. They don't spontaneously come forth and know how to do this. Somebody had to tell these computers, these machines, these algorithms, what is good, what is bad, or that's probably too simplistic, but basically what is falling within the acceptable criteria and what is an outlier or what is excluded. What that means basically is the model can only be as good as it is trained to be. If garbage is put in, then garbage is what you are going to get out. So with that short introduction of AI, we'll just quickly run through a history of artificial intelligence. AI first made its entrance on the world stage in 1950 when Alan Turing publishes Computer, Machinery, and Intelligence. In this work, Turing proposes the question, can machines think? Which henceforth has kind of become the standard for the Turing test. In the Turing test, three players, player C, is asked to determine whether player A or B is a computer and which is a human. Alan Turing was a computer scientist who basically helped the Allies crack the Enigma code, which is what the Germans were using in World War II. And there's a great movie of a fictionalized account of that called The Imitation Game, starring Benedict Cumberbatch. It is a great movie. I highly recommend watching it, especially if you're interested in kind of the origins or World War II. It's a great film. So from 1950, we move on to 1956, where John McCarthy coins the term AI, artificial intelligence. Almost 10 years later, Frank Rosenblatt builds the Mark I perceptron, the first computer based on a neural network or a mind network that has learned, quote unquote, through trial and error. Just 1 year later, Marvin Minsky and Seymour Papert publish a book titled Perceptrons, which becomes both landmark work on neural networks and, at least for a while, an argument against future neural network research. So this is just a side comment from me here. Only 17 years after Turing publishes the very first work on computer intelligence, and 1 year after the first computer-based neural network comes online, the very first warning against future research into AI emerges. Now, we see major players in AI coming out constantly warning against this technology, warning we should slow things down or halt. And I would just like to say that that is a through line since basically the inception of AI. Okay, from here, 1967, we jump ahead a long way, 1995. And by the way, this history is from IBM.com. All the links for all the references I make in the show will be listed in the show notes. So jumping ahead to 1995, Stuart Russell and Peter Novig publish AI, A Modern Approach, which becomes one of the leading textbooks in the study of AI. 97, IBM's Deep Blue beats world chess champion Garry Kasparov in a chess match. 2004, John McCarthy writes a paper, What is AI?, and proposes an off-cited definition of AI. Jumping ahead to 2011, IBM Watson beats champions Ken Jennings and Brad Rutter at Jeopardy! In 2015, Baidu's Minhua supercomputer uses a special kind of deep neural network to identify and categorize images with a higher rate of accuracy than the average human. 2016, DeepMind's AlphaGo program beats Lee Sodal, the world champion Go player, in a 5-game match. Now, this doesn't mean very much to me, but thankfully IBM.com gave me some context. They said that the victory is significant because of a huge number of possible moves as the game progresses, with over 14.5 trillion different move options after just 4 moves. Later, Google would go on to purchase the DeepMind technology for a reported $400 million. And then in 2023, a rise in large language models, or LLMs, such as ChatGPT, create an enormous change in performance of AI and its potential to drive enterprise value. With these generative AI practices, deep learning models can be pre-trained on vast amounts of raw, unlabeled data. And that raw, unlabeled part is very critical because, as I said kind of at the top of the show, somebody has to tell the models what the data means, at least at the beginning. So now that we have a brief and probably very simplistic history of artificial intelligence, we're going to go through the different types of AI. And so in my research, again, a lot of this is from IBM.com. This article is IBM Artificial Intelligence Types. There are 3 different classes of AI capabilities. AI can either be weak, strong, or super. All of the AI that exists today, whether it's a large language model like ChatGPT or anything in the Boston Dynamics robots or Tesla auto-driving cars, all of that today is classified under the weak AI structure. It is artificial intelligence or machine learning that can be trained to do a specific task, just one thing. And while these things are great and amazing, it is still just one thing. The Tesla car can only self-drive. It cannot also do my taxes. The strong AI classification uses previous learnings and skills to accomplish new tasks in a different context without the need of human beings training them on the underlying model. So this is, like I said, where your Tesla car would then suddenly be able to regulate the temperature in your house when you change the thermostat to 69 degrees every Saturday. Like, it's a crazy example, but they can't do that. Super intelligence, the last classification, is intelligence that would surpass all known intelligence across multiple domains. And this type of intelligence would have beliefs and desires all of its own. This is what the worst case scenario fears are when we think of artificial intelligence. Those are 3 different types of classifications based off of capability, but there are 4 different types of AI based off of function. So a little bit of a distinction here. There is reactive machine AI. This is no memory, as in the machine learning doesn't have any memory. It just is to perform a very specific task. For example, Netflix recommendations. You then have limited memory AI. This is AI that can recall past events and monitor specific objects over time. It blends past and present data to decide on a course of action. For example, this would be ChatGPT, Siri, Alexa, and self-driving cars. Then there is the theory of mind AI, which is unrealized today. This does not exist yet today, and it would understand the thoughts and emotions of other entities. Then there is the self-aware AI. Again, this is that last super AI classification. If ever achieved, it would have the ability to understand its own internal conditions and traits along with human emotions and thoughts. It would also have its own set of emotions, needs, beliefs, or whatever the facsimile of that would be for a machine. But again, theory of mind and self-aware AI do not exist today. They are not achieved. As I stated a couple times now, all AI so far has to be trained, and at this point, the machines have to be taught what to do, and there are several different layers depending on what you are wishing to accomplish with the AI. Given that, you will hear phrases like machine learning or neural network or something like that. So what are those things? Let's jump in and explore a little bit more. Machine learning is a branch of artificial intelligence and computer science that focuses on the using of data and algorithms to enable AI to imitate the way humans learn, gradually improving its accuracy. This data comes from IBM's article entitled Machine Learning. So what are some examples? Some examples would be speech recognition, so Siri, speech to text on your phone, anything like that. Online chatbots. We hear stories of, car dealerships having online chatbots that give them a legally binding deal of purchasing a car for $1. It's a real story that happened, I think, to Ford. But any of these online chatbots would fall under machine learning. Computer vision. This allows computers to analyze pictures or videos and take some action. So think like Facebook or your iPhone facial recognition for tagging people. This technology is also included in self-driving cars. And then recommendation engines, so suggested add-ons when checking out at an online store. If you like this, consider these things. Or similar customers also bought blah, blah, blah. And then also fraud detection. So banks use this to detect suspicious transactions. Didn't really give me a lot more information there. Probably smart. But that is some of the things for examples for machine learning. To dive it down a little bit further, UC Berkeley breaks machine learning into 3 phases. There is a decision process, and I believe that this holds true for all future types that we're going to cover as well. There is a decision process where machine learning algorithms are used to make a prediction or a classification. Based off of some input data, the algorithm will produce an estimate about the pattern in the data. An error function. The error function then evaluates the prediction of the model. If there are known examples, an error function can make a comparison to assess the accuracy of the model. And then a model optimization process. If the model can fit better to the data points in the training set, then weights are added to reduce the discrepancy between the known examples and the model estimate. The algorithm will repeat this iterative evaluate and optimize process, updating weights anonymously until a threshold of accuracy has been met. But again, this does rely at first on humans to tell the AI, what is good and what is bad, right? What did you do a good job on and what did you include that shouldn't have been included? Basically, it is like a observe, orient, decide, act kind of thing where you constantly are in this loop of evaluating something, making a decision on it, and then looking at the result and then analyzing the process to see, did the result yield the right expectation or was I incorrect? That was machine learning. We dive one Russian nesting doll deeper into neural networks. Neural networks really had a breakthrough in 2012 when we were able to simulate how the brain worked. Some examples are language translation, image recognition, speech recognition, and image creation. Neural networks are made up of nodes with an input layer and an output layer. Each node acts as an artificial neuron simulated in our brain. And each of these artificial neurons, these nodes, are connected to one another. Each node has a weight and a threshold. This is a little bit technical, but I think we can figure it out. If the output, like I said, each node has an input and an output. If the output reaches a threshold, then the node activates, sending data to the next layer. So kind of think of it like a fountain, like a series of fountains made up of buckets. And so when the top bucket overflows, when it reaches its threshold, it then sends water overflowing into the next deeper bucket, and so on and so forth. So you kind of have this cascading effect, and that is how the neural networks operate. Again, they perform similar functions as a machine learning. It's just at a deeper and more complex level. And then finally, what is deep learning? Deep learning models can be trained on labeled or unlabeled data sets and determine one category from another. So they actually kind of have a leg up compared to the other 2 models where they're able to look at data and then make the decision themselves what is, should be included and what is excluded. So this is probably way too simplistic, but when you get those CAPTCHAs that say, identify all the streetlights in the photo, like this type of deep learning AI can make those decisions on its own without the trainers telling it what to do and what not to do. What makes an AI system deep is that it just contains 4 or more nodes. So it's similar to neural networks. It's just more complex. It's deeper. It has more of a higher level operating of functionality. Deep learning and neural networks are credited with accelerating progress in areas such as computer vision, natural language processing, and speech recognition. Some examples, in addition, would include systems that generate content and predictive maintenance. So a big thing for manufacturing or inventory orders, things like that, where the system can look at the past trends and identify when it's time to reorder something, or when it's time to perform maintenance on your car. It's typically things like that. I also wanted to just quickly talk about large language model. This is more of a specific drill down into this type of AI because it is more commonly applied to things like ChatGPT. So what is that? What do people mean when they say a large language model? An LLM is a category of foundation model trained on immense amounts of data, making them capable of understanding and generating natural language and other types of content to perform a variety of tasks. Again, this is from IBM's website. What that basically means is that LLMs are designed to understand and generate text like a human. They have been trained over millions and billions, probably billions of words to, when given a question, generate a response back. From IBM, they have the ability to infer from context, generate coherent and contextually relevant responses, translate to languages other than English, summarize text, answer questions in general conversation or like frequently asked questions, and even insist in creative writing or code generation. So some computer science people can use things like ChatGPT to, or other, OpenAI, whatever, to help fix code because they can train it on how good code is written for computer programming. These LLMs can help to correct mistakes found in code. The downside of that is that if you are using an open source, generally browser accessible AI system to do code editing, you are then giving your proprietary code to OpenAI or to Google or to whomever to train their system. So do not do that. I don't recommend doing that. If it's a solo project, whatever, again, that's a legal question. But I know that for my organization, we are strictly prohibited from using publicly available AI to find errors or improve our code. With all of that being said, I know it's probably a little bit of a deep, so we can come out, take a breath, take a breather. That I think is the most technical that we're going to get, at least for a while. We're now going to talk about some of the challenges with AI. So the first challenge, the one that we'll just get out of the way first, is the singularity, the superintelligence. When the AI becomes all-powerful, it's more capable than humans across every domain. Thankfully, we are not at this point, but it is worth noting, and that will be a challenge if and when we get there. For sure, impacts on jobs, right? I mean, this is one of the first things that comes to mind when you talk about AI is the jobs that exist today. How many of those things can be enhanced or reduced or completely eliminated by having a machine do it for us? I think that will have a huge impact in the not so distant future and is already having an impact. We will need more people who are knowledgeable on how to train these models. Again, I keep saying garbage in, garbage out. The models have to be trained, but you don't want people that are winging it to train these models if they're going to be performing important functional tasks. So we need to have really smart people who are capable of adapting this technology and making sure that it's applicable and accurate and unbiased. One of the things that comes to mind for me is we get on social media companies so much about the algorithm and the censorship and blah blah blah. At least we've talked about it before in the Reframers, but this is a huge potential issue where these companies that will be providing large language models or other technologies what's the transparency? What right do we have as consumers of this service, of these services, to know how the models are being trained and if the information coming out of them is going to be reliable or not? So that's a big deal. I kind of jumped ahead out of the jobs category, but basically the models are going to need to be maintained and improved upon and maintenance, and that is one category. Then also the actual product itself will have a huge impact on menial task jobs or even advanced jobs. And I also suspect that we might have knowledge loss as a society, not just America, but around the world, of knowledge loss on how to do things the old-fashioned way. We already see that, with people that are not able to fix their cars in the way, myself included, I'm not saying I'm above this, but basically our ability to do things when the technology enables us to not have to. I only suspect that it will get worse as AI becomes more and more capable. The next challenge I see for AI is privacy, and this we will certainly be digging into more. But how can we be sure that our personal data is not mishandled or data mined or used to train AI models without our consent? I suspect that this is a huge area of abuse in the future. I suspect that our government, at least in the United States, will be slow to enact any type of protections against AI abuse. And I already see some examples of Facebook and certainly probably Instagram, as well as Adobe, that are using our personal pictures and projects and things like that to train their own AI systems that are just updated in the terms of service. So certainly we will be getting more into the privacy issue as I learn more about it, but it's a big concern. The last thing I want to say for privacy is just imagine inputting into ChatGPT, give me so-and-so's personal data. And unless there are exclusions in place to have that type of response, where does so-and-so live? That's a really scary idea to me. Now, I don't know that you or I would be necessarily capable of doing that. Maybe the folks at ChatGPT or OpenAI have safeguards against that. But what about hackers? Would they be able to come in and do something like that? I don't know, but it is a risk. We have data breaches coming from existing corporations today, banks and 23andMe and blah, blah, blah. So what's to say that some of these AI companies couldn't also be hacked with massive amounts of personal and sensitive information? The next thing that is a challenge in my mind is bias and discrimination. So I've already mentioned the garbage in, garbage out, but one of the things that makes it more tangible is, I believe it was Google's AI system. Once it was released, users put in, show me a picture of George Washington, and it generated a photo, or brought up a photo, I think it generated it, of a black man. And so that just goes to show that there is it's really important who's training the models and what their mindset is. I think in the interest of trying to be inclusive and trying to eliminate bias, Google probably trained its AI models to be more multicultural and more diverse, but it sacrificed accuracy because we know George Washington was not black. There's already a case of Amazon that had a hiring tool, an AI hiring tool, that was favoring men over women for technical jobs. Basically, what happened was the AI model was trained off of the last 10 years of previous applicants. And because most of the time in the past, men were hired for those roles, the system basically incorporated in as a qualification to do the role that men were weighted more favorably than women. So those are just a couple of really quick examples, but bias and discrimination are absolutely going to be an issue, especially if you get these types of tools in the hands of law enforcement. I suspect there will be some really interesting and challenging civil rights cases coming down when somebody gets misidentified or racially profiled or what have you. So just another challenge. And then I kind of mentioned it above for the privacy thing, but hacking. If rogue elements or malicious state actors or whatever terrorists are acquiring collected data and altering the algorithm or even just obtaining the data and using it for malicious purposes, election interference, whatever. That's a huge problem that I don't think we are equipped to deal with today, and potentially could have huge, huge ramifications. The book that I read that I mentioned in the introduction, Jack Carr's Terminal List, the seventh book, there's a issue where a supercomputer comes in and makes some character's self-driving car drive off the road into, a semi-truck, something like that. Yeah, what if you created a virus that was able to do that type of thing, as we've seen terrorists or foreign enemy states do to infrastructure, things like that. I'm sure there are plenty more challenges, but these are just 5 or 6 that I thought would be pertinent, and I look forward to exploring each of these things a little bit more in depth with all of you. So I think that about wraps it up for today. We're covered a lot of ground. If you need to re-listen for some of the technical stuff and have questions, please let me know. I am not an expert in this. I've just started researching all of these things. So please let me know if you have any questions or clarifications that would be useful. I really hope it was useful to give you a bit of a context about the history, terminology, and process that it means to be artificially intelligent as a system. We will be going forward to dive more into specific topics. The next episode is on phishing and the different types of phishing, that kind of thing. So please like and share the podcasts on Apple or Spotify. Send it to anybody who's interested in AI or learning about this kind of stuff. And you can submit questions to me at ReframersPod on Instagram, or email me at reframerspod@gmail.com if you have any suggestions for future shows or something that you personally would like to know more about. So thank you all so much. Thank you for support on the new show, New Domains, and we'll see you next time.